Hello, I'm Valerio Baiocchi from La Sapienza University of Rome, Italy, and I'm here to present our work on the use of a latest generation mobile phone sensor for the three-dimensional reconstruction of an archaeological monument, the Intihuatana stone in Machu Picchu, Peru. This work is the result of a collaboration between the La Sapienza University of Rome, Partenopei University of Naples in Italy, and Lima University of Peru. The survey of archaeological remains present particular and specific needs and difficulties. In fact, they must be as complete as possible and geometrically correct and georeferenced as accurate as possible. Unfortunately, these needs often encounter problems of difficult accessibility and also of timing and complex logistical conditions. The latest generation mobile phones have more than 100 megapixel optical sensor and, even if they do not have the geometric characteristic of accuracy of a professional camera, they can be used to reconstruct three-dimensional models with structure from motion techniques. At the same time, the SAE mobile phone are developing GPS GNSS positioning features until recently available only in professional GPS, and therefore allowing positioning in the decimeter-centimeter order of accuracy. The use of sensors integrated in a mobile phone greatly simplifies the survey, both for the greater ease of portability and because they do not need authorization from the competent authorities, because they are exactly the same devices that tourists bring with them when they visit the same sites. The proposed approach is made possible by the features integrated within the same telephone device, which have been tested in a quick survey in the Intihuatana zone in Machu Picchu. For this experimentation, a Xiaomi Mi 9 phone was used because at the time of the experimentation itself, April 2019, it was considered one of the most advanced from the point of view of both the camera and the GPS receiver. In fact, it has a 48 megapixel main camera, a 12 megapixel telephoto camera, and a 16 megapixel ultra-wide angle. For the present experiment, part of the survey was made with the 48 megapixel camera, but the whole survey was done with the wide-angular camera. The images were all acquired in JPG format because only more recently the Google Camera application allowed to obtain image in RAW format from Xiaomi Mi 9 phone. As we said, the same mobile phone has GNSS dual frequency capabilities and can allow to survey in static mode the ground control points on the only points that have been made collimable on the same images. In this case, they were the top of the fence poles that we'll see later. To write the post-processing files, the Renexon version 1.3 application was used, which currently only allows to write code observation with this terminal. This is due to a limitation of the specific terminal because, in fact, on the Xiaomi Mi 8, its predecessor, it was possible to write phase observation. The post-processing was carried out with the free RTKlib 2.4.2 software, which allows to easily process the multi-frequency multi-constellation data. In this photo, we can see the well-known archaeological site of Machu Picchu, and in the red circle, the exact location of the Intihuatana stone within the excavation site itself. It is easy to observe how the Intihuatana stone is located at the highest point of the inhabited area of the city. The Intihuatana stone were present in almost all Inca cities, but their function is not entirely clear even today. According to some authors, Intihuatana stone of Machu Picchu was the end of a ceremonial journey that started every year from Cusco and arrived to Machu Picchu. Here we can see the three-dimensional model of the Intihuatana stone obtained from the image acquired with the mobile phone. Agisoft Metashape software version 1.5.0 was used for the elaboration. The top of the fence posts that can be seen here were acquired with the differential GPS within the same phone and used to georeference inside the model. It can be observed that due to the presence of the fence itself, it was possible to acquire only the front of the monument, while its back is not covered by the photos, so the 3D model was not properly reconstructed in that part. To verify the quality of the model obtained, it was compared with the only existing model freely available of the same monument. It was acquired a few years ago by the University of Arkansas and by the UCLA University. This model was acquired with laser scanning techniques and georeferenced only locally. Here we can see the photogrammetric model and the laser scanning model co-registered. Obviously, the laser scan model was registered on our model because our model was georeferenced, and the laser scan model instead it was not. Here we can see instead where are the greatest difference between the two models calculated with the M3C2 command of Cloud Compare. Obviously, the difference are between the two co-register models because, as we said, the laser scanning model has no georeferencing. We can observe that in any case, the differences are limited to a few centimeters. Here we can see more in detail the distribution of the differences between the two models, where we see that the largest class is the one corresponding to the value of 0, and this occurrence is expected because the two models are co-registered one over the other. But more in detail, what is more interesting is that we can observe that the overall differences are contained within plus 3 centimeters and minus 3 centimeters. That is a good value of accuracy. We also evaluated the possibility of reconstruction the missing part of the model with two software. One is the 3D scanner software in Android environment, and the other is the TRNIO in iOS environment. The two software gave different results, and the first software in fact gave unsatisfactory results that we do not report here because they are not acceptable, while the second provided a plausible reconstruction. It is important anyway to underline that a reconstruction is obviously metrically unreliable. In this figure, instead, we can see the comparison between the points surveyed by the mobile phone GPS in red and the 1 to 650 scale cartography, which is below. That is the most accurate layer that we were able to compare with our survey. On the same cartography is reported a trigonometric point that is present in the area, but unfortunately it was not possible to identify it with certainty in the field. In conclusion, we can say that the purpose of this work was to verify if it is possible to carry out a complete survey using only sensors present inside the latest generation mobile phone. And in the case of an archaeological remains, we found that it was a successful experience. Relative comparison between the two models co-registered one over the other showed centimetric shift mainly contained in 3 centimeters. This result is absolutely acceptable, mainly in consideration of the important logistic simplification. The comparison in absolute terms between what was surveyed by the GNSS GPS receiver was not completely possible because the reference model was not georeferenced and there are not trigonometric point or benchmark surely identifiable. But we observed a positioning in the order of 1 meter or less of the GPS point, which is satisfactory, both consider the acquisition time, the only code capabilities, and the distance between the points and the permanent station of the Peruvian reference system that were around 80-100 kilometers far from the survey site. Further experimentation will be developed with cellular phone capable of writing phase observation in post-processing file. It is important, in fact, to underline that Xiaomi Mi9 that we tested here is indeed able of acquiring the phase signal also in the 2 frequency, but it is not able to write it in the RENEX format file. This is very important because with the phase observation it is possible to elaborate the data in precise point positioning modality. And this is very useful when the permanent stations are very far from the site of survey, like in this case where the nearest permanent station were at 80 to 100 kilometers from the survey site. Furthermore, the ever-increasing capabilities of optical sensors that are now available in latest generation mobile telephone with more than 100 megapixels must be evaluated, and it has to be verified if the raw format instead of JPG that we used here can help to have even more detailed photogrammetric models. Thank you for your attention.